This is part 2 of the interpreting motion graph videos. So here we will cover acceleration graphs. Up top here we have kind of the cheat sheet which tells you everything that happens, whether the graph goes up, down, etc. I wanted to keep that in the view so you could see it as we were talking and so I can reference it. If you're looking at this, not as a position graph, not as a velocity graph, but we're looking at it as acceleration. So that would be right down here. Sorry, this ends up covering it's 0, 1, 2, 3, 4, 5, and 6 meters per second per second. So we're going to ignore this stuff here. I made one graph to represent position, velocity, and acceleration. So that's why you've got 3 different options on your y-axis there. So just like with position and velocity, we are going to start with our flat lines because that's where there is no change. So it's the easiest to interpret. So we'll start with, I'm going to actually label the different sections of the graph. 1, 2, 3, 4, 5, 6, and 7. Okay, so starting with this flat line here, if we always want to look at what's going on in the y-axis. So we know it's a flat line, no change, but we have to remember we're not changing our position, we're not changing our velocity. It's no increase or decrease in acceleration. So for this time, for seconds 1, 2, and 3, we are accelerating at 5 meters per second per second. So right here, it is constant acceleration. I'll put constant acceleration. That means that every single second we're speeding up by 5 meters per second per second. So that means we'd be going 5, then 10, then 15, then 20, then 25, then 30, etc. if we continued at that rate of acceleration. So we're speeding up by the same size jumps. Right? Our rise is the same amount there. It's going up by jumps of 5. If we look at this flat line happens to line up with 0. So we have a constant acceleration once again. So I'm just going to kind of put a note from over here. 3, which references this 3, is also constant acceleration. But it's constant acceleration at 0 meters per second per second. So that means that we are not accelerating. Of 0 meters per second per second. So we are not accelerating. However, does that mean we're going very slowly? It doesn't. We could be going really, really fast, really, really slow, or not moving at all. Remember that because this is an acceleration graph, not a position, not a velocity graph, all this is telling us is whether we are speeding up or slowing down. So here, at flat line number 3, we are not speeding up, we are not slowing down. But it doesn't tell us anything about how fast we're going. We could be going 1,000,000 miles an hour, and in an hour from now, we're still going 1,000,000 miles an hour because we haven't accelerated. We have not sped up, we have not slowed down. We could be going 1 mile an hour, right? Really, really slowly. And in 6 days from now, we're still going 1 mile an hour. All this is telling us is that we have constant acceleration of 0. We're not speeding up, we're not slowing down, but it does not tell us what our speed is. So if we come over here to 5, right, we'll put a little note over here for 5, it will be just like 1 or 3 in that it's constant acceleration because it's a flat line. However, a question to get you thinking about 1, I'll put a 1 here, about 1 versus 5. Which one are we accelerating faster at? Are we accelerating faster at flat line 1 or at flat line 5? We are accelerating faster at flat line 5, at flat line 1 because we're moving 5 meters per second per second. Here, if we line this up, it lines up with 3 meters per second per second. So we're going up by jumps of 3. Here we're going up by jumps of 5. So here we'd be going 5, 10, 15, 20, 25, 30. Here we'd be going 30, 33, 36, 39, 42, 45. Right? We'd be going up by smaller jumps. So if our flat line is lower on the y-axis, it tells us that our rise is smaller. This is the same thing as rise over run in math class. If we're lower on the y-axis, it means that our jumps are getting smaller. We're going up by 3s rather than by 5s over here. Okay, constant acceleration of 3 meters per second, meaning every second we're going up by a jump of 3 meters per second. Okay, so excuse me. If we take a look at our final flat line over here, number 7, I want you to notice something interesting. It's at -1. So if we are accelerating, again, it's a constant acceleration of -1 meters per second. That means that we're actually, negative acceleration means we are slowing down. Okay, so right here we are getting slower by -1, by jumps of 1 going down. So from 50 to 49, 48, 47, 46, 45, etc. So this minus sign, anything below this line of 0 here is going to be negative acceleration or slowing down. So that tells us that everything from here up is positive acceleration, and everything from here down is negative acceleration. So that tells us something interesting about 2, 4, and 6, at least until 6 gets to right here. That tells us that 2, 4, and 6 are all positive acceleration, even though they're going up or down. So let's take a closer look at those. So when we're looking at interval 2 here, we would think that we're getting slower, right? Because the line's going down. But remember, we're just looking at acceleration. So I'm going to do a little squiggly line here. These are our constant accelerations. If we're looking at 2, our acceleration is decreasing, right? We can tell that. Our acceleration is going from 5 to 4 to 3 to 2 to 1 to 0 meters per second. However, even if we're accelerating by 4 rather than 5 meters per second, or 1 rather than 5, we're still accelerating. We're just not accelerating as much. We're going up here by jumps of 1. Here we're going up by jumps of 5. So whether we're going up by a jump of 5 meters per second or a jump of 1 meters per second, we are still getting faster that entire time. So if the graph goes down right here, you're accelerating slower, but you are still accelerating or speeding up, just not as fast. So in interval 2 here, your acceleration is decreasing, but still getting faster, right? You are still going faster every single second. You're just not doing it as quickly. Here, if we stayed at this rate of acceleration, you'd be going up by jumps of 5, 10, 15, 20. Here you're going up by jumps of 4, 20, 24, 28, 32, jumps of 3, so from 32 to 35 to 38 to 41. Now jumps of 2, 41 to 43 to 45 to 47 to 49, 51, 52, 53, 54, right? So we're still getting faster at all of these times, just not as quickly. Now, in interval number 4 here, right, this is 4. In interval number 4, our acceleration is increasing. So we're not only increasing our acceleration, but by how much we're getting faster is going up. So rather than accelerating at 0 meters per second, so not at all, we're just staying the same speed, we're now going up by jumps of 1, jumps of 2, and then jumps of 3. So how quickly we're getting faster is getting faster. Remember, acceleration is a rate of a rate. So here we are increasing how much we are increasing our speed by. Kind of confusing to think about. And in number 6, it's the same as number 2 here. We are still accelerating, but at a slower rate, from 3 to 2 to 1 to 0. Now something interesting happens where that x is. Acceleration is decreasing, but still getting faster. Like you are still getting faster until we hit this x spot right here. Once we hit that x spot, we stop accelerating. And as soon as we go anywhere below it, we are now in negatives, right? We have crossed over from the positives, right? Here's our negative line. That's where 0 is. So as soon as we're down here, we're in our negatives, meaning we're slowing down. So number 6, our acceleration is decreasing, but we're still getting faster until we get negative, right? And then once we're negative, we are slowing down, right? Like here, constant A, acceleration, we're slowing down. So what this tells us is that in time 1, 2, 3, 4, 5, 6, at least 6 until this point right here, all of that is speeding up. We're only slowing down from second, just before second 10 through 12. I guess that probably counts as second 10 through 12 is when we're when we're slowing down at all. So the rest of this graph, even though it's flatline or decreasing or at 0, all of this is speeding up, or at least right here, staying the same speed. Only at this x do we finally start to slow down. So we have to remember that just because the line is going down doesn't tell us that our speed is going down. It just tells us our acceleration, or by how much our jumps are getting bigger. Those are getting slightly smaller, right? Rather than jumps of 5, they're jumps of 4, 3, 2, or 1 if the line goes down. But that doesn't mean we're getting slower. The whole time we're still getting faster. So what I wanted to do was one more little visual here. I'm going to erase this stuff on the graph here. So keeping all of this in mind and keeping our notes to the side here. Okay. What I'm going to do is I'm going to draw a line that's going to represent velocity, your speed. So if for this time here, for the first 3 seconds, we are increasing by jumps of 5, our velocity, now remember this is not going to be drawn exactly to scale, our velocity is going to be getting faster, right? At a pretty good clip here. It's a pretty good rate, pretty high slope, right? We're making big jumps. Here, in what is number 2, our acceleration is decreasing, but we're still getting faster. So if we're increasing our speed, but just not as quickly, that means our slope would not be as steep. So it would look something like that, right? Still going up, but not as quickly as it was here. So this would be 1, that would be 2. So remember, for 3, right here, we are constant acceleration of 0, meaning we're not accelerating, meaning our speed is constant. Right? So now here, the rate at which we're speeding up is getting faster. So it would be something like that, right? It's slowly getting faster. And then here, we're making jumps of 3, so it's going to look something like that, making jumps of 3. Here, that rate of acceleration is slowing down, but we're still getting faster, so it looks something like this, until we hit 10, and boom, we start going down. Negative acceleration, start decreasing. And actually not that fast. I'm going to erase that because it's not going to be very steep at all. We're going down by jumps of -1. So it's going to be something actually more like that. So as you can see, until we hit right here where it goes negative, I'm going to put that x back, right? Until this point, everything has been positive acceleration, or at least staying the same right here. So as you can see from a velocity graph, we would have gotten a lot faster in this time until this x point where it's at about 10 seconds, and we decrease a little bit. We decrease 1 meter per second over 2 seconds. So we would go down by 2 meters per second in total right there. So I know this is a confusing graph. That's why for this one you don't need to talk about exactly what's happening at seconds 1 to 3 versus seconds 4 to 6. But I just generally want you to understand when you see an acceleration graph that flatlines or goes down or goes up or whatever, know what that is telling us about our speed, right? What does that mean is happening? And the fact that anything positive means we're getting faster. Anything negative means we're going slower. And 0 just means we're not speeding up or slowing down, but doesn't tell us exactly how fast we're going. Just means our speed is not changing. Thank you.